Thank you for choosing our video on solving systems of linear equations. My name is Gabby and I'm coming to you from the Villanova University Math Learning Resource Center. This is the first in a three-part series of videos on how to solve systems of equations. The method that we're going to be focusing on first here is solving systems by graphing. I like to start with solving systems by graphing because I think it gives us a nice visual representation of what's happening when we solve a system of equations. So let's start with a system of equations. X plus y equals 1, and let's say negative 2x plus 4y equals 4. So here we have a system of equations. We have two equations with two variables in each. Now what we're looking for is a value for each variable, a value for x and a value for y, that satisfies both of these equations. So we can think about this as a coordinate on a graph, where here are our x values and here are our y values, and this value xy that satisfies both of these equations is sitting somewhere here in the plane. Now the way that we can solve for this point xy by graphing is to note that each of these equations here has a geometric graphical representation in this very same plane. Each one of these is a line on the plane. And we'll find that when we draw these lines are actually both going to cross through this point xy. The point that satisfies both equations is going to be the point of intersection of the two lines on our graph. So the easiest way to graph these lines to find that point is to take each one of these and put it into slope-intercept form. Now there are a variety of ways to graph these equations, and you can choose whichever way works best for you. The easiest way for me is to put these in slope-intercept form or translate them to the form y equals mx plus b, where m is our slope, b is our y-intercept. So let's go ahead and solve our first equation to put it into this form, slope-intercept form. So the easiest way to put this in slope-intercept form is just to subtract this x value from both sides. And that'll leave us with y equals negative x plus 1. We are now in slope-intercept form. Here our slope, m, is negative 1, and our y-intercept, b, is 1. Okay, so similarly for our next equation, we're just going to add this x, this 2x, to both sides. Again, we're trying to get this y isolated here. So that leaves us with 4y equals, 2x plus 4. Now if we divide everything by 4, that leaves us with, go over here, y equals 1/2 x plus 1. And again, we are now in slope-intercept form where our slope is a half and our y-intercept is 1. So let's go ahead and graph those. I'm going to erase our theoretical point of intersection, and we'll find our new point of intersection by graphing these lines that are now in slope-intercept form, which we have just found. So to graph these, I'll start with the first equation here. It looks like our y-intercept is 1, which means our equation is going to cross the y-axis right here at this coordinate, 0, 1. And we have a slope of negative 1, which means we're going to go down 1, over 1, down 1, over 1. And our line is going to look like this. A little something like that. Okay, so one line down, one to go. Let's go ahead and do our second line. So it turns out this one also has a y-intercept of 1. So it's going to intersect the y-axis also at this point 1. So we actually, before we've even finished graphing the second line, found our point of intersection. Just to give you an idea about what it looks like, the slope is 1/2, so we're going to go up 1/2 over 1, up 1/2 over 1, and it looks a little something like this. But most importantly, we found this value, 0, 1, so x is equal to 0, and y is equal to 1, to be the value that satisfies both of our original equations that we had here.